Chapter 13, Problem 33. A 60-kilogram woman stands at the rim of a horizontal turntable having a moment of inertia of 500 kilogram meters squared and radius of 2.0 meters. The turntable is initially at rest and is free to rotate about a frictionless vertical axle through its center. The woman then starts walking around the rim clockwise, as viewed from above the system, at a constant speed of 1.5 meters per second relative to the Earth. A. In what direction and with what angular speed does the turntable rotate? B. How much work does the woman do to set herself and the turntable into motion? Now let's take a look at the givens. We have the mass of the woman being 60.0 kilograms, her moments of inertia being 500 kilogram meters squared, the radius of the turntable being 2 meters, and the speed of rotation clockwise being 1.50 meters per second relative to the Earth. So to solve part A, we have to take into consideration that the table turns in the opposite direction of the way the woman walks. So its angular momentum is going to cancel out with that of the woman's. So using the conservation of angular momentum for the system, we have that the final angular momentum is equal to the initial angular momentum, which is equal to 0. So we get that the final angular momentum is equal to the moments of inertia of the woman times the angular velocity of the woman plus the moments of inertia of the table times the angular velocity of the table, which is equal to 0. And the angular velocity of the table is equal to negative moments of inertia of the woman over the moments of inertia of the table times the angular velocity of the woman. And doing more simplification, we get that it is negative mass of the woman times radius squared over moments of inertia of the table times the velocity of the woman over the radius. So this is just using definitions of moments of inertia and angular velocity and plugging in those values, and which is going to simplify down to negative mass of the woman times the radius times the velocity of the woman over the moments of inertia of the table. Now solving for the angular velocity of the table, plugging in the values we have, we get 60 kilograms for the mass times 2 meters for the radius times 1.5 meters per second for the velocity, all divided by the moments of inertia, 500 kilogram meters squared, which is equal to negative 0.360 radians per second. Or you can rewrite it as the angular velocity of the table is equal to 0.360 radians per second, but counterclockwise. So to solve part B, we use the work kinetic energy theorem, and we get the work done is equal to the change in kinetic energy, which is equal to the final kinetic energy minus the initial kinetic energy, which is 0 in this case because the turntable starts off at rest. And rewriting the final kinetic energy, we get 1/2 mass of the woman times the velocity of the woman squared plus 1/2 moments of inertia times angular velocity squared of the table. So this is going to be the final kinetic energy of the entire system. And solving, plugging in values, we get that the work done is equal to 1/2 mass of the woman is 60 kilograms times her velocity, 1.50 meters per second, quantity squared, plus 1/2 the times the moments of inertia, 500 kilogram meters squared, times the angular velocity of the table, which is 0.360 radians per second, quantity squared. And solving all that out, you should get 99.9 joules.